For calculus is actually super easy. This is the algebraic way to basically find the area underneath the curve. Okay? So if f is continuous, it's a continuous function on the interval, f is the antiderivative, then basically to figure this out, the area underneath the curve, you will find the antiderivative, remember that's represented with a capital F, and then basically you plug in b, and then you subtract it when you plug in a. So if you look, this was our problem of the day. This problem, the integral from 0 to 2 of x squared plus 1 dx. So what you do is you take the derivative of the function, that's how we got 1/3 x cubed plus x, and we're going to evaluate it from 0 to 2. So you plug in 2 everywhere you see an x, you plug in 0 everywhere you see an x, and then you subtract it. And then it's just some algebra. Now if you try to do this in your calculator to check it, you would see that you would get the same answer of 14/3. So let's look at some problems. First thing we need to do is find the derivative of our function. The derivative of u minus 1 is 1/2 u squared plus u. That's our derivative. We're going to evaluate that from -2 to 1. And again, it's very simple. All you do is you plug in 1 into u, and then you're going to plug in -2 and then simplify. So 1/2 1 squared plus 1 minus 1/2 -2 squared plus a -2. And let's do some math. This is going to be a 1/2 plus 1 minus over here. -2 squared is a positive 4. Half of that is 2. Minus 2. Oop, I made a mistake. I don't know if anyone's caught it. You see why I put a plus here? That is wrong. That should be a minus. The reason why it should be a minus is because it was a -1 at the top. So all of these should be negatives. So that's going to change a couple of things here. I do apologize. Hopefully this didn't mess anybody up. So it's a minus. This ends up being a plus. So now I'm going to basically have -1/2 minus 4, which is -9/2. Let's look at C before we look at B, since I got a little more space down here. First thing you think I might want to do, make it a little nicer, distribute. Because I can find the derivative of 4x cubed minus 4x squared. That's going to be x to the 4th minus 4/3 x cubed. That's going to get evaluated from 1 to 3. So that means I'm going to plug in a 3 in for x, and I'm going to subtract it from whatever I get when I plug in 1. Okay? Now it's just algebra. 3 to the 4th is 81. 4/3 times 3 cubed is 36, so I'm going to minus 36. Minus 1 to the 4th is 1, minus 4/3. So when I do this, after I do my math, now again, all these can be done without a calculator because, you know, they're pretty simple fractions. You should get 1/36/3 for your final answer. And that's going to basically, again, these numbers represent the area underneath the curve. If I look at B, I probably want to bring this up, don't I? Make it a little nicer for myself. Or actually, what I can do, what is the antiderivative of 1/t? That's right, it's ln of t. So I can evaluate that from 3 to 2. So then I'll get ln of 3 minus the ln of 2. And if this was a non-calculator problem, I can only go one more further step to say it's the ln of 3/2. Do not forget your rules or your laws of logarithms allows you to do just that. Would you get the same thing if you brought the t up and made it negative? Yes. Maybe not. It just, I actually haven't tried it that other way. Let's look at these. These involve a little bit more. All right? So I take the antiderivative of e to the 2x. Well, that's nothing but 1/2 e to the 2x. Do not forget, those are one of those special properties. The same time we learned about the linear factors. Those are one of those special ones. And then, of course, here, this can be written as x to the -2 to give me a -1x to the -1 as I evaluate that from 1 to 5. Okay? So So it's going to be 1/2 e to the 10 minus 1/5. I'm going to go ahead and convert that back to a positive exponent. Minus 1/2 e to the 2 minus 1. Now combining some like terms and such, I'll have 1/2 e to the 10th minus 1/2 e squared. Then 2 negatives make a positive, and then I'll end up with a positive 5/4. That would be my area underneath the curve. Every single one of these we're going to do without our calculator. Let's look at E. So linear function, so remember it's 1 over a times 1 over n plus 1, and then n plus 1. I'm going to evaluate that from -1 to 1. 1/2 times 1/4 is 1/8. I'm going to plug in 1 to get 2 minus 3 to the 4th. Then I'm going to plug in -1. So 1/8, -2 minus 3 to the 4th. Do the math. You can do it. Simple algebra from here. Don't use your calculator. You can do it. Yep, you guessed it. It's simplified down to a nice -78. I know, all that work is simplified down to a nice -78. This one over here, I think it would be easier for us to write it as a rational exponent, wouldn't you say? Yep, because now, again, 1 over a times 1 over n plus 1, so that will give me a 2/3. 3x plus 16 raised to the 3/2. Evaluate that from 3 to 0. That means 2/9, and then I plug in 3. That gives me 9 plus 16 raised to the 3/2 minus 2/9, 0 plus 16 raised to the 3/2. Do a little bit of math. Watch out for that negative, and you get an answer of 122 over 9. That's the area underneath the curve for this particular function. Okay? Lastly, G. Lastly, G. G is actually a U substitution problem. Do you see it? I'm going to make U 2x squared plus 1. I'm going to make du 4x dx. And as you see, this can now be written as the integral from 0 to 1 of u squared du. Well, the derivative of u squared is 1/3 u to the 3rd. And I'm going to evaluate that from 0 to 1. The only thing is, before I start plugging in, I probably want the function, whatever u was, before I evaluate it from 1 to 0. Okay? So when I plug it in, it's going to be 1/3. 1 squared times 2 plus 1 is 3. And I'm going to subtract that from 1/3, 1 cubed. Simplify that down. 1/3 of 27 is 9. Minus 1/3. And so my final answer is going to be 8 2/3, or 26 over 3. And that's the definite integral. That's the fundamental theorem of calculus. Remember, you don't need any plus c's because that's only for indefinite integrals. With definite integrals, we're actually going to get, areas underneath the curve, so there's actual numbers here. Okay? So try the homework. Let me know if you have any questions. Bring them with you to class tomorrow, and I will see you guys then.